Hey, I'm Marcus, Product Director at MedStack. And in this video, I'm going to take you through the product onboarding experience for the MedStack Control product. So MedStack Control is a platform with out-of-the-box tools to build, deploy, maintain, and audit your digital health applications in healthcare compliant cloud environments. In this product onboarding, we're going to go through about 10 different sections pretty quickly. The first one will be some prerequisites about deploying and building on MedStack Control. The second will be a high-level architectural overview, what networking looks like on the application. We'll talk about setting up some local dev environments to, essentially prepare for deploying on MedStack Control. We'll talk about setting up your company and your team. We'll get into building a cluster. And once you start building a cluster, that policy, data privacy, and security inheritance model, as well as our support for vendor security assessments as a result of running on MedStack. We'll talk about deploying a sample application, which we have a React application for you all to deploy. The telemetry that you get in the platform, API and webhook integrations into a CI/CD deployment pipeline, and of course, our go-to-production guide that includes information about migrating to the platform, doing capacity planning and scaling onto Control, as well as some of the best practices. So lots of stuff to cover. Let's get into it. First thing is the before you build section. So before you build on Control, there are some key application requirements. You'll need to have your product containerized and capable of running in a Docker environment. You'll need to build essentially in a Linux-based framework. So most web development frameworks are just fine. And then you'll want to have a private registry where you can push these container images to, so that essentially you can pull them down into Control for deployment. There are some recommendations that we have, as well as the shared responsibility diagram available in our support docs. We'll really quickly go over this. There's 4 parts to the shared responsibility stack. The base layer is the cloud provider, which is like the hypervisor that the actual cloud infrastructure runs on. There's the layer of MedStack Control that does all the provisioning and managed services on top of that cloud provider. And then there are the administrative controls and data compliance program. That's essentially a GRC tools. We have a product called Exos by MedStack that covers that part of the stack in our product suite. We'll touch on it a little bit in this demo, but we won't go too deep into it. And then, of course, there's you, the customer, who has a responsibility across some platform, some security, and some compliance aspects. That's all covered here in the shared responsibility diagram. If we head over to the technical overview section, we'll see the networking. And the networking is pretty straightforward. Essentially, there's the MedStack Control cluster, which is like a private network or a VPC that contains all of your cloud resources. MedStack manages the provisioning of that cloud infrastructure, as well as the managed Docker environment within it. And the load balancer that handles all the traffic proxying into the cluster. So as a managed load balancer service, MedStack's able to guarantee encryption in transit for any kind of client request coming into the application, because everything's flowing through the load balancer over standard web requests, so port 443. Behind that, you can run any service. In this example, we have like an Nginx web server. It could be Apache. You could even forego the web server entirely and go directly to any of your services arbitrarily, an API or a front end or any microservice. That application layer in Docker is able to communicate with the database server and the object storage that you also can choose to power into your MedStack Control cluster. And it's all secured behind these multiple layers of defense, basically reducing the attack surface area of any kind of cyber threat. When we're talking about deploying, this is pretty straightforward. So essentially, you have your code, you'll have any kind of pipeline activity, and then you'll do some basic Docker build, Docker push, and that'll go directly to a container registry. So once it's on your private container registry, you can use a webhook or the MedStack Control API to pull that image down. You tell it how to run it in Docker on MedStack Control, and then it spins up inside that cluster. That's a really, really simple view of what the architecture looks like in deploying to the platform. Now, as for your local dev environments, well, you'll want to set up just like Docker Hub locally on your machine. That'll be like Docker for desktop or something like that. And there's some key benefits and limits of using Docker on MedStack Control that are kind of all covered here. Why we chose Docker, the scalability, the portability aspects that are really amazing for running as part of this platform on Control. Let's head over very quickly into the security section that covers all the different parts of the managed security layer, or the active security layer that's happening. Things like a monitored system information and event management system. There's third-party assessments, so MedStack themselves are SOC 2 certified, and part of that inheritance model means that you can also inherit our report as part of your own SOC 2 evidence with certain auditors as well, which really accelerates that process. A whole bunch of other really amazing things here in this documentation. Strongly encourage you to check it out to learn a little bit more about the security program that's just built into the platform that you get by running your apps on Control. When you're inside MedStack Control, this is the dashboard. So whoever first receives the invitation and sets up the company will be able to go here into their company settings and start inviting users. So when you invite a user, you just do it by their email address, and there are 4 different role types. The scope of those roles is explained in the support documentation, and then everyone who creates an account has to set up 2-factor authentication as part of like a secondary layer of defense on protecting the account, knowing your customer, and making sure that PHI is safeguarded, if at all, inside these environments that run in Control. The second part to kind of setting up a company is establishing this notification list. So a notification list is really just it's a bunch of email endpoints. So we support up to 3 email endpoints for a company space, where you can put like a PagerDuty integration or a Slack email integration, or even an email distribution list that would receive notices of, say, maintenance, of node down alerts, or node utilization threshold alerts. A whole bunch of information could just pass on through and integrate into your other systems through a standard email integration. Let's dive a little bit into building a cluster. So we have 2 clusters that are built here already. And if we go and create a new cluster, you can just apply any arbitrary label. This could be like a test cluster, and you can specify the region. There's a whole bunch of regions that we support. And whatever region you decide to spin it up in, MedStack Control is promising that we're able to spin up that cluster with the provisions that are necessary for safely handling the healthcare data in those different geographies and those different compliance regions. So we'll go ahead and just create this one. But while it's provisioning, we'll actually go look into like a cluster that's already been spun up. It takes maybe like a minute or 2 to spin that up and apply all the provisions to it. But for example, some of those things are like instantiating the backup system, or the overlay network, the encryption network that it encrypts all the data that's either in transit and at rest. Very quickly, I'll take you through kind of some of what that inheritance model looks like. So as you start spinning up any of the 3 key resources inside of a cluster, that could be nodes, which are really the vertical and horizontal scaling aspects of your application that add CPU or memory horsepower to your actual Docker application. There's database servers, so dedicated, scalable database servers that interact directly with your application. And then storage accounts, which are great for storing unstructured data like videos, photos, PDFs that might relate to healthcare data. That could be scans, MRIs, things like that. They can go into this unstructured storage account that would be essentially protected and having the necessary safeguards to safely handle that data in a healthcare application. So the different kinds of safeguards that are applied are all covered in that security program, but they're also published here in MedStack's information privacy and security policies. So for example, if you want to learn about how MedStack's backup system works, it's detailed here and says, for example, for all those virtual machines, those nodes, backups are happening hourly, and those hourly backups are retained for 1 day. Those daily backups are retained for 1 week, and so on and so forth for the life cycle policy on retaining those backups. So if you're also using Exos by MedStack, there's a really nice integration here. So while we provide you with all of these inheritable policies, Exos is actually a platform that we've pre-authored the policies directly as they relate to users running on MedStack Control. So for example, we can go to like the backup policy here. And in the clauses section, we've linked it to the different HIPAA or the different PIPEDA the different clauses of those frameworks. And we've also related it to MedStack control itself. So the MedStack control backup policy is connected to the data backup and storage policy that like a security and compliance team could adopt into their policies. And also the procedures that are connected with that. So say you have to go through like a data backup event, or you need to prove that data backup exists inside of control. A policy or a procedure like this could be kicked off. In this case, it would be like contacting MedStack support. We actually very recently built a feature that allows you to self-service something like this. And so part of this is giving a tight integration between the two products. It's just going to be really exciting. So you could head over and actually like list the backups that have been happening on the platform. And so while this list is generating, there's quite a few backups in this particular cluster. But information about like the backup location, the encryption status, and even the compressed size will help indicate where that backup is, the size of it, which can be used for validation, and the timestamp, the interval, and other necessary information about being able to prove that a backup is in place. So I would export that, and you can upload it directly into Exos as evidence. And that is essentially how the technical team can work hand in hand with the security and compliance team to make sure that what's actually says that you're getting out of the platform is provided, and really the attestations match the actual implementation. So if you're using Exos and MedStack together, it streamlines the way that these two teams that typically are ran by different departments are actually just unified and working together in a single front through the MedStack control platform. So let's head back here into the platform. There's one more thing that's worth highlighting as it relates to the attestations. And so there's a bunch of security controls that get applied to a cluster. And sometimes there are situations where if you're running on MedStack control and part of your business is to sell to hospitals or healthcare enterprises, you can actually take a vendor security assessment that they give you, which is like a series of questions about your security and your practices. All of those are actually detailed in the policies and the procedures that you get by running on MedStack that we give you through Exos. You can take that vendor security assessment and you can give it to us at MedStack, and we put it through a natural language processing engine that does matching between the different policies and procedures and the question that you're being asked. So in many cases, MedStack is able to provide up to 90% of completion on that vendor security assessment. So all you have to worry about are the remaining 10% of pieces, which are generally the pieces that sit inside the customer's shared responsibility model. But everything else that's covered by the GRC platform, the way that we are a managed service layer in between, and then on top of the hypervisor themselves inheriting their BAA, we're able to answer a fairly huge degree of a vendor security assessment just because you're running on MedStack control. Exos gives you the actual policies and procedures to author and make those attestations too, as your business needs. So it all comes together into this unified product experience of inheriting this amazing compliance program. And development teams, and technical teams just need to focus on creating infrastructure and deploying their applications to it while these safeguards are automatically happening. So I'll take you to a spot in our documentation that actually goes through deploying a sample React application. This goes through like creating the React app, Dockerizing it, building that as an image, storing it on Docker Hub, and then eventually deploying it to MedStack control, creating like a DNS record to point to the cluster, and then spinning it up and actually running it to the public internet. So this is a really easy and accessible guide on our docs to go through. Strongly encourage you to check that one out. As for actually managing the Docker application, there's pretty much like four key sections here. So you have your service, which is essentially the configuration of a Docker service, so like a Docker file. You have your secrets, which you would mount securely into the service itself. Configs as well, which would configure at runtime the services. And then volumes, if you have any data locality or local data that you need to run in a stateful container, you would create data volumes and they get backed up per the MedStack backup policy and all that. So really quickly, I can show you as well, like spinning up a custom service. This is MedStack's managed load balancer service. So you deploy that at the end. when you want to go live, and that's where all your traffic will proxy through. But for spinning up most services that you're building, it's custom services where you would specify the name, the image of this. Image could be something like the library / my app, and then you would give it a tag like V10 or something like that, a version of your application. Yeah, the replicas indicate the horizontal scaling of this service, so the number of containers that run across the fleet, and they balance across based off of whatever capacity planning you have. Domain mapping for getting it live to the open internet, so this could be ran at like api.company.com or something like that. You would create a DNS record to match to the domain and to the IP address of the machine that this runs on. And then a couple of really nice parts for continuity. So especially if you're running an application in a hospital setting where you need to have very high availability, using load balancer health checks and update strategy, you're able to reduce the downtime of your application when you're doing deployments. So this allows teams to basically accelerate their maturity, their DevOps health as a company, so that they're able to make more deployments and effectively deliver more iterative changes to their users faster with less disruption. Other key pieces to this service configuration are environment variables, configs, secrets, and volume mounts, and then placement strains for data locality. You can add all of these elements. Again, there's nothing too novel here. This is just translating what exists in your Docker file, your Docker Compose for your services, and telling MedStack how to download the container image from your registry and spin it up in the localized managed Docker environment here on control. Once you have an application that's running, a service that's running, there's a few neat things that you can do with it. So for example, if we have like a web application that we have spun up here, the domain that is hosted on would be like, in this case, it's particledemo.medstack.net. You can navigate right there and see that we have like a live application that's actually running. This one's just like a simple little registry for patient data. But you can actually shell directly into the services or even view service logs. So this would be any logs across the service that are exposing information about standard error and standard out from the service. And if you have a service that has like a web terminal interface, for example, we have like a small admin utility that runs here as another custom service. You can shell directly into services and instantiate them or do any kind of operation directly inside of the web shell here. So that's one degree of telemetry. Another degree of telemetry would be actually right in the Docker containers and the nodes themselves. So I can view metrics here for like, say, the manager node on this cluster. And this would give me visibility into like the CPU, the memory utilization metrics for both the containers and the actual node itself, as well as any kind of storage utilization or storage consumption on that machine itself. You're able to scale up the CPU and the memory resources just by using like a node resize. You also have the ability to restore volume directly to a node, so you have that control to do data restoration both for your database server and for your Docker environment, and even troubleshooting efforts to do like a reboot or a redeployment of this node in case you run into any issues, and do self-service maintenance, configure alerting rules, which will tell you information about like to the notification list when a node hits a certain capacity on CPU or memory. So there's a lot of different pieces to telemetry that you can set up that come out of the box and are included here to basically give development teams what they need for the telemetry into managing their applications on the platform. One of the second last pieces here that I wanted to go over is the CI/CD pipeline. So ideally, a great user experience in MedStack Control is one where you don't even need to come into the product to make deployments to it. And that's where the API comes in super handy. So we have a comprehensive API reference that essentially does everything that you would be able to do inside managed Docker. So that means provisioning, services, secrets, configs, and volumes can all be done using the API. You can put that API into any deployment pipeline, and it uses basic authentication to be able to make these kinds of commands. So that means that firing off a deployment pipeline, anyone in your team can actually do that using the MedStack Control API. There's also a webhook integration that can be used for doing similar operations in your CI/CD pipeline. And we do have a CI/CD quick start guide as well that we reference through our go to production guide. So there's a lot of resources on getting your team set up and equipped with everything that you need to be successful on MedStack Control. The last piece I want to go through here is our go to production guide that just takes teams through some of the strategies to be most successful on the platform. So that would include things like, setting up the right capacity planning for your clusters, the right balancing to have, say, a multi-node strategy in case any of these nodes goes down. There's another node that can take the workloads from, of containers from one node and pass it off to the next in case there's any kind of failure, things like that. So there are quite a few recommendations that we have, and we still wanted to give teams the ability to own and manage their own capacity planning, their own strategies, instead of completely obfuscating what's happening in terms of running your applications. So DevOps teams in particular love this tool because they get all these security controls, all this redundancy that's built into the box. And effectively, they need to set up the telemetry stacks, the integrations to any system that they need to manage the application for really great high availability applications. So that's a bit through our go to production guide. There's lots of information here that can be read through, and a really comprehensive guide. Really, MedStack focuses on the building, the deploying, and the maintaining aspects of that DevOps lifecycle. And as a user, you would depend on MedStack for doing those aspects of that DevOps lifecycle. It's a managed platform that handles these in HIPAA compliant environments, but even more than that, if you're seeking out SOC 2 certification, GDPR, our platform is capable of getting you those degrees of certifications as a technical platform. So there's a bunch on our marketing website that even indicates the different compliance frameworks that we can help you adhere to and operate in those different geographies. So that's a little bit about MedStack Control. And if you have any questions, you can certainly reach out to our teams, whether that's our sales team or our support team. And we look forward to having you in our application and changing the way that healthcare is innovated on by lowering the barrier to building digital health applications. Thanks very much for listening.